Awesome. How many of you writing code here? Almost all. Okay, good. How many of you using an IDE? All right. Those who are not, raise their hands. Are you still using Notepad? No? Okay. How many of you are using LLM for writing your code or getting some assistance? Okay, a little bit, 20%, 30%. How many of you deployed your code that came out of LLM? Very few? A little bit? Okay, cool. That's what migration is all about, right? The transformation of what you're doing and our day-to-day, how it changes. That's what migration is. And that's my topic. So it includes like fixing small tech debts to like changing all the technologies that you're using inside your application. That's what migration is all about. And that's what I'm going to talk today. A case study on massive migration. Before that, I'm Sendil. I'm an engineering manager at Uber. And yeah, you can reach out to me at this handle. That's what I do. And I work in a payments department. So anything like if you're ever paid to Uber or ever paid by Uber, most of the things that you got paid or most of the tech rails that happens beneath the scenes are built by my team. So that's what I do. All right. This is the agenda for the talk. We will start with, of course, by migration. And then we'll go with two tales or two stories that I have about migration that I've been part of. And how we ran that massive migration that I wanted to talk to you about, and then the lessons learned out of it. And last one, yeah, let's see if we have time. Migrations can be multiple different types, right? Like anybody here has not done a migration yet in their life? One? Okay. Have you never like upgraded your NPM dependency to? All right, yeah. So migrations can be different types. It can be small, it can be massive. If it goes beyond a limit, we call it a transformation. And there are various ways of migration that we have. Like, I'm not going to write to the slide, but there are like different types of migration that you have. And they are hard. They are hard, complex problems in engineering. In fact, like as engineers, we are trained to deliver things forward. We write code, we deploy in production, we go home, sleep, and turn on call. But on the other hand, migrations is like you have to actually think about how you're going to roll back your stuff. Like you're writing forward, but you also have to think about like what will happen when something fails, which we are not trained to do properly. And we have this kind of problems. Like it is very unnatural for us, and that's why migrations are a very hard and complex problem in computer science overall. And there are multiple points of failure in a migration. Things can go weird at any place. There might be one piece of code that nobody wants to touch in your, okay, just a question. How many of you have a code that your team is afraid to touch or change? See? Yeah. So you will definitely have this kind of thing. So there are multiple points of failure in a migration, and it's very difficult for you to converge everything together and deliver a migration properly. So yeah. So why migrations? Why do you think we should do migrations? Anybody? Shoutouts? No? Sorry? Yeah, stay competitive. That's a good one. Yeah. That's true. Yeah. Good. We are going to talk about it. Yeah, go for it. Okay. Okay. I can see where this is coming from. Good. All right. So why migrations? Definitely, it helps you to improve performance. I don't have to do a lot of more talkings over there because when we migrated from Flow to TypeScript, we were able to identify like our builds were like 40% faster than compared to what it was in Flow. That was a huge improvement for us in terms of performance. It reduces cost of your application. It has a lot of impact on cost. Here, I'm not talking about like a front-end migration. You can talk about a database migration or something like that where you can benefit a lot by reducing the cost, doing the migrations properly. It improves user experience, of course, yes. And it reduces churn inside your team. That is also one of the basic things. Like when we are using Flow, everybody was struggling. Everybody was literally frustrated. When we moved to TypeScript, people are a little bit happy over it. But plain JavaScript is always better. That's my stance on that. But it reduces churn inside the team. It also improves scalability and security of your application. Is any Java developers in the room? Okay, have you done the log4j migration? Okay. So yeah, it improves scalability and security. And it also improves your developer experience and productivity. And that is one of the major fundamental foundation for any migration. And there are like hundreds of other reasons why migrations are important. So let's consider an imaginary company. I'm not talking about any company here, an imaginary company. They like in this world for like 10 years. So over the growth, like at year one, they'll be like in a constant exponential growth phase where they try to build up their application rapidly and deliver things. And then in 2 to 4 years, they kind of expand. They bring in more developers inside the team, and they also expand on their business. And then after that, around 5+ years, they are making money. And then 10 years, we are going to call them as a legacy company. So let's consider this as a company. This is a company, any company. And the complexity of the migration actually exponentially increases as the number of years the code lives in that production. For example, when you're starting a company, you could start with Java or Kotlin because it was fancy that time. And then quickly in a year, you can change to Rust or Go because the amount of code that you're going to migrate is very less. And that means your migration complexity is smaller. But as the company grows, 10+ years of company, if you try to migrate anything, you have to have process in place. And that we hate, right? And then there is also there are multiple studies that has been done where every migration that we're trying to do in a company which has 10% more developers. So for example, if you have 10 developers today, tomorrow when you bring in 11th developer, the cost of migration actually increases by 15%. So the cost of migration also increases as your company grows or it starts to live. And finally, the other thing is also that I have visibly seen the developer happiness in a company. Like when you go to a startup and say to a person hey, tomorrow you're going to rewrite the entire Kotlin library into Go, people will be very happy with that. But when you go and tell this in 10 years plus application, people will shout at you. So yeah, that's basically what's happening. And there are multiple other dimensions too. For example, the users, the tools, the services that you're using, and all those things adds a complexity and a dimension to the problem. So this graph actually gets multiplied with all those factors that we are factoring in. So it is very difficult to do migration. And yeah, with that, I'm going to the next stage of the presentation, two tails. The first one is Angular to React. This is actually in my previous company, where we migrated from AngularJS to React. And it was a fun process. It was a very small startup. And we had, let's just consider this imaginary application. We had an application called Releaser, which has AngularJS frontend, runs on JVM backend. It's a legacy application. It has a lot of things inside it. It built for more than 10 years. And it has around it's not a big application. It's a small application, 2,000 files of JavaScript. It was quite small application. And then it is a business critical application for us. The entire money that comes to the startup is basically coming from this single application. So it is very, very important for this. And then a new self-proclaimed tech lead came and joined our team. And then he said okay, we have to move towards React because it's new and it's fashionable. So they decided to build another application, which is called as Deployer. And they completely revamped and written that in react.js. This was great for the team that is working on Deployer. It is very small. It has just 200 files. And it also built with an awesome UI library. We spent if the application development for the Deployer is 5 years, we would have spent 4 years finishing that awesome UI library. So that much amount of effort we have done in order to just deliver this application. It is great. But as you know, the developer experience, the productivity, and all those things were super high on Deployer, but on Releaser, everything was going down. People are really not happy with it. People were every time the time to deliver on the Deployer is much faster because they have all those beautiful library written in and the power of the framework and everything. And the poor folks from Releaser was in AngularJS. With that, you can guess who were the poor folks in the room. So we had few options to do. We thought okay, we want to migrate. We decided let's go to React completely. Let's scrap all this AngularJS and just go to React. So there are multiple options that we had. One is completely replace everything. So our mission critical application, we want to stop building new features into it, but just go ahead and change it to React. The second thing is develop things in parallel, stop all the new features, but just enhance React more and more. Or progressive migration, which basically converts Angular to React in a step-by-step process by running both of them together. And as a people who wants both impact as well as having new features into it, just like everybody else, we decided on going progressive migration. It was very good at the beginning. So in the progressive migration, it's basically like we want to run both Angular and React runtime together in the same application. Anybody has done that? Okay. You know the pain, right? Okay. So what we did was like in React runtime, we said like we will build all the new features into it. While in Angular, we'll just put in and keep the lights on mode, and we don't touch anything. We'll just migrate feature by feature into React. It was a great idea when it started, but it didn't go well. And our life during the migration, it increased the developer time. Everything that we have to do twice, or at least 1.5 times more in the new world of like managed or merged runtimes. The new features were like really not prioritized at all. So sorry, new feature was really prioritized all the ways, and we did not do any migration of AngularJS to React. So whatever that 2,000 files that we had kept on being AngularJS till the end of the lifecycle of the application. And they're like, sorry. And they're also like, we did not have proper tests to run it. The legacy code was like very difficult for us to migrate, so we kind of stopped it. We in fact had one portion of the code where we have created a huge calendar user interface, and somebody in my team, 4 years before or something like that, decided to write that entire application in Scala. That is a user interface application, but they have written in a beautiful poetic Scala. Nobody wants to touch a piece of code. So nobody migrated that anytime. And our application became really slow. So that was very painful for that. And we could see visibly in the team itself, the churn inside the team has increased, and the number of people inside the team also decreased significantly. Like more than 50% of the team actually left the job and moved away. There are multiple reasons to it, but this is one of the main reasons, I would say. So migration failed completely. And the worst part of that is like everybody's so enthusiastic about this migration, started to accept this is a life, and they moved on with the same structure that still exists. Like they have the shared runtime that is Steven today running. We used to support IE8 with the shared runtime. Yeah, life was terrible, yeah. So this application still lives in that context, and it makes it very difficult for anybody to move forward and suggest a new migration in the system. And then move forward like 3-4 years after that, the flow to TypeScript happened. This was one of the migration when I was working at Uber. I remember like when I was interviewing at Uber, during my hiring manager session, I asked the question like, why are you still using Flow? Because nobody likes it in the ecosystem. Why are you still using it? And my manager's reply was like really the biggest thing that pushed me into joining the company. He was like, yeah, that's correct. You can come join to the company and change it. And during that time, being in an interview, I have to show my positive face. I said like, yeah, okay, I'll join the company within a month or so. I'll go ahead and change Flow to TypeScript. I joined the company, and 3.5 years later, it happened, but I was just a part of it. So yeah. So you know Uber runs microservices. So everything that we have inside Uber is a microservice. And one thing that I cannot fathom is like we have more number of microservices than compared to number of developers or engineers in the company. So it is something really awesome. And we have this technology called Fusion.js. So Fusion.js is basically Next.js kind of application with an Express server, backend server, and a React plus Flow as the main language to write your application and components. It is an open source project. You can look at the Fusion.js. It includes all the bells and whistles. So as a developer, you need not think about like, hey, how to do observability for this, how to add in the login features for this and all those things. It will be automatically taken care. So it kind of like builds in all the bells and features. It is built based on plugin-based architecture. So you can also add your plugins together. And it uses Flow, which is a major compliant for everybody. And we had around few hundred services that is running this code. And literally we had around like more than 10 million lines of code that is actually in Flow. And we wanted to migrate this entire thing into TypeScript. It was a massive effort. And have the Flow. Did I ask this question before? I felt like I asked it. How many of you using Flow still? One person. Okay, we need to catch up after this. So while preparing for this talk, I went through the website of Flow and said like what they are doing now. And these 3 things popped up. These are the 3 major things that they put down in their website. If you go to their homepage, you can see this. They're saying like you can code smarter with Flow, you can code faster with Flow, and we can also code confident with Flow. All 3 we find it wrong when we were working on Flow. So, but their website says this. But they had an amazing type inference. The type inference in Flow is like really good. We really enjoy doing that. It was like, it kind of like assumes the type inference better than compared with other libraries. But it was built on OCaml, which kind of like, it's one of the downfall, I would say, because not many contributors are helping over there. And they have this library called flow type, which is equivalent to definitely typed. So they're like all the main libraries and all those things. They expose typing information for those things. But it was there. And we had a lot of issues with flow. One of the main thing that kind of like still I remember from my development days is like type system is not that great, and you get to see errors. Few times, you just have to rerun the application to ensure the errors are not happening again. And that shows the flakiness in the errors, or flakiness in the type system and type checker, which was very, very difficult for us to do. And it was poorly maintained, I would say. There is a link on this presentation. I'll really put the presentation out after this talk, where like they said like the direction of how they wanted to address and how they want to handle open source, which made it like, okay, we're not going forward in that direction. And the other major thing is like the compile times were always a bigger issue for us because it takes a longer time to compile. And our time to land also increases by 30% because we do extensive testing. And one of the things is like we have to test the types, and it takes forever to run, even on the servers. And the most important thing is like, if you go to the code, you could see this line, the flow fix me, a lot of times. People are like trying to subvert from the type system. It's like using any in the type system, right? So they don't want to use anything there. They just want to just fix it. Because if you're fixing some type information, especially when you have complex types like map and stuff like that, your flow system will not properly identify them, and you will consistently have issues in that code base. So what they did was like, people just went ahead and say like, okay, the error is happening for 2 times. I cannot fix it. Let me just add this line. There are a lot of flow fix me lines in the code. And everybody was literally frustrated with it. Like outside the world, everybody was using TypeScript. People are happy or show us that they are happy. But on the end of the day, people are very, very frustrated with Flow.js. So yeah, we wanted to migrate it to TypeScript. The reason why we choose separate, it should be obvious for everybody. It has a very, very predictable type system. If it fails consistently. Not like Flow where like inconsistency is there. It fails consistently. It also has definitely typed. One of the major things that also like very important for us is like it has a very good IDE support. And by VS Code or any IDE that you use, it has a very good support. The type inference was great. I've not called it as like as good as what we had in Flow, but the type inference was good. It was becoming a de facto standard on the front-end ecosystem, and there were like much less breaking changes. For me, the most important thing is the predictability and less breaking change. For you, it can be different, and that is the reason why we chose TypeScript. All right, we chose TypeScript, and how did we run this migration? One of the things that came up pretty top is like you cannot stop the world. Uber has to keep on going, so we cannot do anything without like we cannot propose a solution that kind of like stops, revamps the application, builds it newly, and then deliver it. No, that's not possible. So no stop the world change has to be there. Which was pretty complex, right, to run at that scale. So what we did was like we first sit together as engineers, plan the migration, say like, okay, this is what we want to do. How are we going to do it? And then we documented it, and then signed off on the document. So these 3 things is pretty common in Uber and also in any of the companies. Like when you propose a change, you go sit together with your fellow engineers, propose a model, propose a document, share the document, get a sign-off wildly. And then what we did was like, the very first step that we did was like we started to automate things. We were looking into ways in which like we can convert Flow to TypeScript by automatically. One of my colleagues, Bogdan, from my team, he started writing this application called Flow.js, which actually converted Flow to TypeScript straight away. And that's an open source library that is available. I'll also link that with that presentation, which converts Flow to TypeScript. Somebody over there said they are using Flow. You can try using that library, which would help. And we executed it at small scale. Bogdan actually went ahead and changed Babel. He proposed changes in the Babel and all the subsequent frameworks and libraries that we were using. And we executed it at a small scale. We took a small library, a small framework, and then converted that thing into TypeScript. And we tested. We confirmed everything works, the automation works, the code that we're generating is meaningful, and it works properly. Once we have confirmed that, we went ahead and migrated a critical app. We migrated one of the biggest payments app because I'm from payments domain and we have a lot of payments app that is running with Flow. So what we did was we migrated the payments app. That was a very critical app that is used by everybody. And then we test and confirm this entire thing. Once we have found that success, or once we have figured out what is missing, how can we fix the automation script, and whatever learning that comes from this, we put it back into the automation script and then rerun everything together. Until we are very confident that everything works, we continue doing this thing. And finally, we completed the migration. And then we released the script to everybody else, to the entire company, and asked the entire company to migrate on top of it. So once we have a success, once we made sure everything is automated, we released it across. And what it basically looked like for us, we built a tool, we migrated something, and then enabled that on the CI/CD pipelines. And then we test, rinse, and repeat everything all together. And then we build the tool. The build tool here, again, is basically we build a tool that enables you to do migration. So tomorrow, if you're migrating your service, you just run one script command. And everything automatically migrates for you, and everything is properly set up for you. And then we migrate smaller services, bigger ones. And then finally, we kind of release the script to everybody. And we supported the migration as a backend. So we kind of made sure everybody migrates to it and then properly addresses this scenario. I think one of the biggest difference between my first migration, Angular to React, Flow to TypeScript, is basically this. The automation was missing for us. And then we did not execute on a small scale. Once we decided we are going to React, we just went ahead and just changed our business critical application to React. We did not test and confirm, even more than that, we did not even have tests running for our existing application. There were literally no tests running, so we cannot validate what we are doing is correct or wrong. And we did not complete the migration, so it was left hanging over there. We did not complete anything, and we did not do anything over there. So the basic lesson for us in terms of learning from the first migration itself is we missed automation completely. Automation is one of the important things. Try to automate if you're doing any migration. Try to automate it. Make sure that everything is automated. We did not have rollback plan. One of the things, if anybody comes to me today and says hey, I want to do migration inside my team, the first question I ask them is do you have a rollback plan? Because it is very important. If you don't have a rollback plan, you will not know what is going to go wrong and how you're going to come out of it. So it's basically very important whenever you do a migration. And the next thing is lack test coverage, which I said before. We did not have any tests, so we cannot validate. Even that Scala code that I was talking about, nobody can validate whether how it works or why it works. So it was always there. And tests are super essential. And another advantage is if you're doing a massive migration, I think having a centralized and decentralized team kind of helps over here. So we have the centralized platform team who takes care of doing that migration for us, who kind of addresses and pushes this principle across. Initially, you could start something hey, you have to do this migration. And then you can go further and say you should do this migration. You must do this migration. If you're not doing migration, you cannot move to production. These kind of stringent rules you can put. And with the help of centralized team, you can actually monitor the progress and also make sure that they're migrating. In my first case, in the Angular to React story, we did not have any team. So we were actually a decentralized team. So we were 2 people from each team kind of gathered around, and we decided we want to migrate. During that time, we cannot enforce these kind of rules. But here, with the centralized team, it is much more easier for us to centralize the rules. So if you are doing a migration, which is huge, try to have a centralized platform team and give them the power and give them the voice so that they can move forward. Yeah. And the lessons learned, I would say, let me go back fully. Yeah. So you have to plan carefully. You have to ensure everything is properly planned from the beginning till the end, what is going to happen. If you're working in a matrix organization, if you have multiple teams together, effectively communicate things across. You have to say to everybody that how things are working, how you're migrating. Test thoroughly, very, very important, I would say. Have a rollback plan. And finally, automate it. If you cannot automate anything, then don't think about migration. Try to automate most of the things that you're going to do. And finally, complete the migration. Do not leave it hanging. People will go out of the company. So compared to migration actually is great for doing a lot of things. It reduces churn inside the team. It reduces the cost if done properly. If it is not done properly, it can significantly impact on the other direction. So it increases the cost for you, it increases the churn inside the team, and all the other things. So how many of you are planning to propose a migration to your leaders? A few? Other people don't want to do any migration. How many are afraid of migrations? Oh my God, there are a lot of people. Okay. Come on, engineers, we should be happy about doing migrations. Yeah. All right, so this is my view on it, so take it with a grain of salt. Getting your leadership approval on migration. You should actually tell them a story. You should first tell them a story why you want to do a migration. What is the best thing that is going to happen? Quantify the benefits that you're going to get for your team, for your company, for you individually. What is the thing? So basically, like, you have to find your pain points and project it in a way such that they understand how this pain point and how it can transfer into your solving those insecurities or problems that you have inside your team. And then propose a plan. You tell them, like, how do you mitigate the risks? Tell them, like, what is the plan in which you're going to do? The mitigated risk actually includes rollback here. I'm emphasizing on rollback and automation because that is one of the key learning for me. So always try to figure out and have a plan and be persistent. Your desire of, like, doing the migration might be shot down at first or second time or even third time, but be persistent. Remember, it took more than 3.5 years for us to do the migration, to get it ready. So it takes a long time. And if somebody in my team is coming to me and asking me, I want to do a migration, these are the first 5 questions that pops up in my head. What is the problem that you have? Why do you want to do that migration? So tell me the impact of what we can get. How would you prevent this kind of thing happening in the future? Propose me a rollback plan. And I would also check whether the person is persistent or not. Like, I want the person to be persistent in terms of, like, they have to really believe in that value. If a person is not believing in the value and just wanted to move to a new solution just because it is fancy, I've not approved of it. So it basically, like, I want to see what is really impacting us and get feedback from there. And with that, planned and well-executed migration provides a meaningful progress on your technical debt, your experience as a developer, and everything else. So those people who dislike migration, try to do it. It's fun. It's the most complex problem that you can do. With that said, thank you very much. We are hiring. If you're interested, reach out to me.
All right. Thank you so much, Sendil.